chance to verify?
Someone take my phone.
You just keep going.
Okay.
Text Mr. Van Sluden, Senior B in my contacts that we're ready to go.
He's probably watching. Here. Where do you want this?
What is that?
Okay, I think you guys should be live.
Live.
But,
These two. One goes here, and then the other one goes on that one. Yeah, it's like that.
Are we live, everybody?
I think you're
I
live.
think we're live. Okay, hi, this is Dr. Knight again. We've relocated to another field. This is soybean field that and the totality here is about 20, 25 minutes or so. And so totality here is about 20 or 25 minutes or so in Nebraska. So it's already happening in different places across the country the way it will move across the United States of shadow. So maybe Jennifer, go ahead, you come here and maybe talk to the students about
Step right here.
about what happened, why is there an eclipse, and how do we know it's today, and that kind of thing. And you guys can start formulating your questions about the eclipse
Closer.
now, and less about the weather balloon.
Microphone's right here.
Oh, okay.
And maybe Jennifer can tell. This is Jennifer Esme.
Hi.
She's one of our Oak Park High School rocket team students, and she's going to tell you a little bit about the eclipse and maybe generate some questions.
I gotta give a phone back.
All right, hold on. It took us a little bit longer to relocate than we had hoped because we wanted to find a place where we could broadcast. So it put us a little behind schedule. Okay, go ahead. We're talking about let's talk about why eclipses occur and that use some of that terminology that we studied.
Okay, so normally, so a moon goes through a rotation every month, and it goes through its normal rotation. It waxes its wings, and it's just based on the position of the Earth compared to the Sun, and then the Sun reflecting off of the Moon so that we see it. So if the Earth isn't tilted at a 5-degree angle on its axis, we should be able to see a total solar eclipse every month. But it isn't this way. It happens like every 2 years since the Earth is tilted slightly. So when the Sun reflects onto the Moon and then like they align and stuff, like a aligning on the line of nodes, it's good words, it doesn't happen except for every 2 years, and it's really scattered across the globe. So normally a total solar eclipse will happen like on the ocean, and no one can see it because you can't get to the ocean that easy.
So think about it this way. So the Earth is actually a ball, and it's actually tilted about 23.5 degrees actually on its axis. Okay, but what's off by 5 degrees is the moon. The moon goes around the Earth like this, and then there's the sun, right? So if everything was all lined up the way you think it probably is in your head, then there would be an eclipse of the moon and an eclipse of the sun every single month. But because the moon's orbit is 5 degrees off center of this, then we have to wait until we get to something called the line of nodes, when the moon crosses right in front of the sun, and then that's what causes the eclipse to happen. So that happens about every 18 months or almost 2 years or so, and it's a very precise cycle, and these can be predicted. But as Jennifer was saying, they're not always in a place that can be easily observed. If they happen in Antarctica or someplace like that where you can't see them, then they're not observable for people. The other thing is that, go ahead.
The moon isn't actually the same size as the sun.
Yeah.
It's just relative perception. So since the moon and the sun, they have a really great ratio. Right now there's a perfect ratio that, do you remember what it is?
Yeah, well, let's say that the sun is 400 times larger than the moon, but the moon is 400 times closer to the Earth. So if you do the math on that, as soon as the moon passes in front of the sun, it blocks it out absolutely perfectly. And what's kind of cool about this is, the moon is moving away from the Earth about an inch a year. And so in about 600 million years, you won't be able to see a total eclipse of the sun anymore. So you better enjoy it while you can, because you're going to have to wait, 600 million years, you won't be able to see them anymore anywhere on the planet.
But you'll be dead.
Yeah, well, that's one of those things, right? So now is always a good time to enjoy the eclipses. In the past, there haven't been eclipses either that actually cover the exact sun and the exact size of it. So that's kind of how eclipses happen. If the moon, by the way, also its orbit around the Earth isn't exactly perfect. It's elliptical. So if you need another alignment to make sure the eclipse happens, because otherwise you get a different type of eclipse. If the moon is further away from the sun, from the Earth at the time of the passing in front of the sun, then you get what's called an annular eclipse, where the moon only obscures a portion of the sun's disk. So, and then you get the total only when the moon is the closest to the Earth. So right now we have the moon is the closest to the Earth, and that's why it's we have a total solar eclipse. And eclipses can only of the sun can only happen during the new moon, which so like tonight, for example, you won't see in the moon because it's here during the day. So on this side of the rotation. So that's some of the things about eclipses. They've been able to be predicted for a very, very long time ago. They were the Greeks and the Egyptians were able to predict eclipses, and we believe that the Aztecs and the Incas also were able to, and the ancient Chinese were able to figure out the cycles of the eclipses. So
47.
They were often used by people who knew that an eclipse was coming to scare people who didn't know that it was coming by saying that the sun is going to go dark, and that would scare people of the past, of course.
So yeah, like Christopher Columbus, he was in trouble when he landed over in the New World.
In Jamaica.
And so he looked into his almanac and he was like, oh, there's going to be a total solar eclipse soon. So he goes out and he says to the people, he goes, you know, if you don't give me and my crew food and you don't do as we wish, I'll make the sun disappear and I won't make it come back. And so then they were kind of like, the Jamaicans were like, no, you can't do that. But then a total solar eclipse happened, and so then they came to him and said, well, do whatever you want, just make the sun come back, because they knew they needed the sun. So then he went into his place and he prayed to make it come back, and then the moon just kept on its orbit and it came back.
It's starting to get dark.
Yeah.
I think it's starting to get
getting
dark.
darker and cooler.
Yeah, the sun is the moon is being covered. The moon is covering the sun now, a little bit of it.
The sun is about 15 or 20% remaining.
So yeah, we're getting close. We're about
75 to 80%.
15 minutes away from the totality that's going to happen, and it's literally around here going to turn to night. So it's going to turn completely dark. There's going to be the sunset is going to be 360 degrees around us, so unlike anything any of us have ever seen. And
in the past 10 minutes, it's gotten 50% darker and a lot cooler.
On the highways today, there were signs this morning that said, flashing lights that said, turn on your headlights during the eclipse. And there was also a warning that was out as, don't wear your eclipse glasses when you're driving on the highways, which we thought was very funny, because if you put those things on, you can't see a thing unless you're looking directly at the sun. It's like this. And of course, this is what you see, nothing. So anyway, we're being really careful with our eye protection today. We have special glasses that we can use to see the sun, and we have binoculars that are for eclipses designed just for that purpose. And we have a telescope that we're setting up behind us that has a big solar filter on it. But you have to be especially careful with binoculars or telescopes, because they increase the power of the sun's rays, and they'll burn your retina and you'll have your eye blind you. And so there will be people today, hopefully people won't do this, but they will look at the sun even just for a short period of time, and they will blind themselves by looking at the sun. It's not any different today than it is any other day. It's just that you have an idea that you want to look at the sun because there's an eclipse going on. You otherwise wouldn't be that interested. So that's why people go blind from eclipses, by looking at it without proper eye protection. So the Rocket team and all of us here today are have everything very carefully ready to go, so that everybody is 100% safe. We're setting up the telescope now. It's going to be taking photographs of the sun itself. As it goes through this, there's some things we're going to be looking to see. If you're watching this on TV, like the NASA feed on the other channels or something like that, you'll see the corona of the sun, which is like, that means in Spanish or the Latin, the crown. And so that's the area, like a halo around the sun that will be visible that you normally can't see. The corona. But the moon blocks the sun, and then that's there. And then just as the solar eclipse begins to happen, and as it's just passing, as the moon passes in front of it, you get something called the diamond ring, which is a little bit of sunlight that's just left.
If you want to bring the iPad over here, we have an image of.
Yeah, okay, so we're going to try to bring the iPad over so you can see what we're seeing through the telescope, and see if we can make that work for you. This is the telescope. That's the sun, obscured by the moon.
Everything looks like surreal.
You can't really tell, but it almost feels like it's the evening here, like 5 or 6 o'clock. We can start to be louder. And the crickets are coming out because they think it's night.
Okay, I can try setting my camera up to take pictures every X amount of intervals. Can someone give me my camera bag?
Yeah. I'll take it there.
Can I use the binoculars? If you have it on like a time lapse setting.
No, yeah, I can do that, but only if I get my camera. Yeah.
I cannot see it.
You have to find it. Look from the bottom and then scan up. Don't look up and then around.
Hey, can you hold this?
Were you able to show them that?
Yeah. Just showing the surrounding area.
So what we're just showing now is like with this area is turning dark. Hopefully you can see that. We're about 11 minutes away or so from totality. So most of the sun's disk is covered, but not all of it. And it makes a huge difference between
99% and 100%.
85%, 90%, and 100%. So we got lots of stuff going on here. The telescope is actually designed to track the sun, so it subtracts the rotation of the Earth, so it stays in place. So we shouldn't have to keep repositioning it for the view. And we are really lucky right now in terms of the weather, because I don't know if you can see it, but there's a massive amount of clouds that are to the east of us, and it's just clear right here. And the sun is in an area where it's perfectly clear. So we're getting nice photographs in a perfectly clear sky. So, which is really lucky, considering that there's a lot of clouds around us.
There's clouds everywhere except
where we are, so we're pretty lucky today with all of this. And it's getting nice and cool. It's been quite hot here, and now it's getting a lot cooler. So it's really very nice.
Connor in Miss J's class is asking where the balloon will land with all that wind.
Okay, well, yeah, okay, go ahead.
It's gonna burst in Aurora and then land near Grand Junction, I believe it's called, but closer to Arborville.
So it's about 50 miles away from where we launched it, but it's in the direction that we have to go back today anyway. All that wind isn't that big of a serious problem, because like I was explaining, when we were launching it, is the wind is on the ground, and as it goes higher, it changes.
It's gonna hit the jet
it's actually going to hit the jet stream of about 100-mile-an-hour winds. I'm not sure what they are today, and it's going to push that balloon even further, but just for a short time, and then the balloon will go out of the jet stream and into the stratosphere where there is very little wind.
We put it into this Cambridge like predictor, so we put in our weight and our payload and where it's gonna burst and everything like that, and so then it mapped us from our starting point to our ending point and also our burst. So it kind of went like this and then back a little, then kept climbing like north.
So less than 10 minutes till totality.
So we're less than 10 minutes now to totality.
Totality is at 1:03
to darken around here right now. We think we noticed the crickets are starting to get louder than when we were here, and we're going to pay attention. There are no other animals around here. We're told that during eclipses, animals will go into their night mode, so as if it's becoming night, they're fooled by it and
they get
curious
confused
about it.
2 minutes later when the sun's
And then the sun comes up again. So, we did pass a herd of cows a minute ago, and they're probably starting to get ready to thinking about going to sleep.
It's really small now.
So these are the glasses that we're using. I'm going to have a look. You notice that I put them on down and then I scan up so I don't put my eyes into the sun.
There's just a tiny sliver of sun left.
And I can't even see it.
You can zoom out with the right thing.
How many people are
See if you can see the land. You can't really see, but it's like surreal. It feels almost like I don't even know.
Yeah.
It doesn't
Real
look
quick.
up on the sun.
Real quick. Shout out to Ellie and Jill.
Here, I can zoom it out for you.
I can't find it through the
Are there any
binoculars.
questions for us?
You can actually see the. Yeah, you can tell. You can see some kind of. 360 degree sunset all around.
Man, this is so.
Oh, there's the diamond ring.
Diamond ring.
Oh my God. Don't look at it. Now that's where you're not allowed to look with your bare eyes. Okay? Stop looking at it.
holy shit, we got one amazing.
Now the eclipse is passing. Now it's brightening again, so the eclipse is passing us, the totality is passing. I have my glasses back on to check it. Yeah, now we're having the sliver on the other side.
Oh my god, it's data. What the heck? That was
Now time is coming back.
Oh my god, that was hard. Okay, we got a good diamond ring picture and we got a good normal picture.
Excellent.
I should have taken out the solar filter sooner.
Pictures.
Because I could have gotten like
I
so
really
many.
hope the balloon's getting great pictures.
Okay, so yeah, we're hoping that our balloon is getting good pictures during all this. It should still be ascending for a little bit longer before it breaks. So, does anybody else have questions?
I'll man the questions.
Do we have any other questions coming in?
Oh, I've got solar flares.
Oh wow, look at that.
That's
Mr.
great, I got one
Kwok
of
just
those
took a
too.
picture
I
of
got
the
one of
solar
those too.
flare.
Did drop.
Right.
Let me
Out
see
the
it.
camera, you guys, please.
Holy crap. That was so cool.
Oh, sorry. I don't know.
That was
Are we still loading? Are we still getting live feed or not?
I think we're good now.
We're good? We're back again?
You just kind of want the sun to...
Oh my god. That was amazing. That was really good.
We need to pick one picture and get it printed.
I can't believe that we did that without clouds.
That was amazing.
Yeah, so it's like a few minutes.
Okay, we're live again, I think.
Yeah.
Right.
Wants
no
to know if
questions
the
coming in?
temperature dropped.
Oh, the temperature dropped probably 10 to 20 degrees. It got literally chilly out here. It really did.
That's cool.
It's still eclipsing, but it's going the other way now. So the eclipse is passing us.
You get like a loop.
So we were very fortunate to have absolutely no clouds in front of the sun during the totality of the eclipse.
Okay.
Okay, you want to show the picture you got?
Can they see?
Yeah, they should be able to see
Yeah,
that.
they can see.
I have this picture.
Okay, yeah.
Something like this. This was overexposed. This was underexposed. This is the solar flare picture. This is a little bit brighter when I...
Get that one framed, definitely.
Yeah.
Beautiful work.
So those are the good ones.
Very nice work. Again, you had to have very special equipment to safely photograph the sun during the eclipse. During the totality, you're actually allowed to look at the sun without glasses.
Excellent.
When it's completely covered by the moon, then it's safe to view the eclipse for that very short period of time. And for us here, it was longer than about 2.5 minutes that was allowed. In this part of the country, the eclipse was longer than it was in a lot of other places. So we were kind of excited about that.
Here, if you zoom in on one of them, you can see solar flares when you zoom in on one of them.
That's so happy.
Well, that's pretty crazy. Okay.
Yeah, that's a solar flare. There's another one towards the bottom.
Yeah, they're like snakes moving across the ground. Yeah,
This one, we could merge this with an HDR software with this one
It's rare to see
and with this one,
Yeah,
and then
that's what the smart.
yeah.
We do like a collage, I think, going in order of pictures.
Again, we're looking up at the sun. Right now we're using our glasses or our binoculars.
Did you see the shadow bands?
No.
I'll show you a video.
So Kobe said he saw shadow bands. He's going to show you a video back on here.
Oh, they're hard to
Let me
see.
show everybody.
Tell me if it's in frame. 'Cause
Okay.
Is it good?
Yeah, that's good.
So it's kind of hard to see, but if you look really closely, you can see ripples. Ripples on the ground.
Oh,
It almost looks
sort
like
of
the
like
asphalt
moving.
is rippling.
Okay.
And that's basically the
Oh yeah, look at that. Wow, that's amazing.
Yeah. That's right when the moon covers the sun.
Right.
So they're actually very rare to see.
Wow, let's see it again. Get it really close.
Red clouds.
Do it again.
So beautiful.
I didn't realize what a short video I took.
Everything was beautiful.
Oh, and if you also looked all around you, you saw a 360-degree sunset.
Yeah, we did that. We went around with the camera to kind of see that. Yeah.
That was cool.
Shout out to Gerardo.
There you go.
Gerardo.
Okay. All right. Are there any other questions coming in? Any other further things?
How much did the temperature drop?
Well, we said about 10 to 20 degrees. We didn't actually record it. Our balloon is recording that, which will be interesting to see. But at that altitude, it may not be a big difference, actually, because the air is not very dense at that altitude. Oh, one of the questions was like, so when's the next eclipse going to be? Well, the next one that's going to come across part of the United States is going to be in 2024. So not that far from now, about 8 years from now, it'll cross the United States.
Although down in South Africa, the next one's in like 2019.
In 2019, there's one in South Africa. Is that right, Matthew?
I mean, no, South America.
South America, okay.
The really bottom portion.
Right, so in Patagonia, Tierra del Fuego, there'll be one in 2019.
The balloon's in its last 30 minutes. Check this spot.
Okay. Okay, we're going to start checking the location of the balloon and see where it's located. Because it's going to be nearing, well, it's been up an hour and a half, so it's still got a little ways to go up till it breaks. Yeah, so about half an hour until it bursts. And let's see what else we wanted to talk about today. Are there any further questions?
Oh, we should tell them when we're gonna do the next live stream to see when we find the balloon.
Yeah, right. So the next big project for us is finding this balloon, which is going to be no easy task. We have our GPS to find it, and then we have to hope that it's not in the middle of a cornfield that we can't get to. So we'll use the drone to help us locate it as well once we know the GPS it's going to be in, and we'll see where it's actually located, and then we'll try to recall. Hopefully, it's in a place we can get it. But one thing we did that we thought was smart is we put our name and phone number on it, so that in case somebody finds it later, if we lose the GPS signal or something like that, then we'll know. Hopefully, somebody will find it and they'll call us up, and then we'll be able to. They can mail it to us if they want it.
Good luck with
Shout out to Surya Thali for making the tag.
Okay, yeah. All right. Any other questions from anybody? All right, we're just gonna let you watch the brightening horizon and let you come up with something.
Oh, the temperature dropped.
I didn't get anything good on my phone. I didn't get my camera.
Do you want to see the shadows there?
Pretty amazing. It's still covered.
Dr. Knight.
With a telescope.
Oh, that's a crazy picture. Let me see.
With a telescope, that looks pretty
Can we
cool.
show?
Amazing picture.
That's the picture of the day.
We should. The telescope looking at the solar eclipse.
I have some photos.
Steve, are you good at editing video?
What's that to your answer?
So it's still eclipsing, but
You can hear that audio on the. You have like.
Can you help me with the shadow band?
So, Dr. Knight.
Someone wants to know how far up in the atmosphere the balloon went.
But we don't know yet.
I think it went like 100,000 is when it burst.
It's supposed to go
We know.
100,000. That's what we calculated.
No, it was at 31,270.
I'm gonna look at it. Hold on.
Yeah, it was 31,270.
They got 5 bars.
31,270 is the bursting.
That's in meters. That's in fake numbers.
That's not fake numbers. That's real
Metric
science.
system.
For frame of reference, that's higher than cruising altitude on an airplane.
Much
It's
higher.
really high.
Yeah, wait, like 40,000 feet higher. Well, the average cruising altitude of a jetliner is around 31,000 feet. Although some jet planes can get up to 60.
Oh yeah, we got the solar flares.
Oh, that's really cool.
Wait, what are you doing?
I'm showing the camera. This is a
Oh, the
Catadioptric lens, Minolta lens on a Sony body. Shooting full frame at 24 megapixels, and you can see the solar prominences and solar flares. Tony, are you getting a read spot?
We are.
Can you show it on the camera?
Sure.
Camera's right up here in this corner.
So this is the tracking of the balloon. Every time that it notified the satellite, it drops a little ping there, and so you can kind of see where it's kind of going. Directing to exactly our model's projected is perfect so far. This up here is the city of Grand Island, Nebraska. So it's south of there at the moment, and I think it's just south of Highway 80.
He's thinking very right.
No, I'm just gonna leave it the way it is.
Yeah, it's getting super bright.
No.
I don't want to become so much brighter all the
Crickets.
time.
They don't understand.
Yeah, this is Highway 80.
That's right.
so that's good. And it's just keeping going in that direction.
As long as it doesn't land on the highway.
Right, we don't want it to land on Highway 80. That wouldn't be a very good thing.
Whatever you want to do.
So the balloon is doing its job. It should be very close. Yeah, it should be very close to its apogee where it's going to burst. And someone might ask, well, how do we know when it's going to land? When we get the ping twice in the same location, then we know that the balloon has landed. But we expect that to take about another hour or so. So all is good with that.
No, it was just a camera that was attached.
Okay.
It wasn't attached.
Are we
It's not a part of the
relocating?
telescope.
No.
We
The
were not
eclipse
gonna.
isn't
Are we
even
gonna
over.
live stream the?
What do I caption
capture
this? Sage, what do I caption this?
Whatever you want to.
Light and dark. Light and dark.
Only American. Only speaking American. Only speaking American. American's a language.
Yo no hablo inglés.
Really awesome. That was really cool.
That has to be the best thing anyone has.
That's true.
Like
That was so awesome. What do I caption this picture?
So I think we're still in the during the eclipse, but there's not much happening now, compared to the totality. So it's just kind of like the sun's behind me, and it's brightening as the sun, as the moon is passing the sun, the disk is passing. We're still monitoring the balloon. It's still okay. I'm not seeing a change. Oh, you're not?
Yeah, like, is there like
Oh, maybe it stopped a while.
yeah, their moon phase, like, there's emoji, like,
No, it's still showing live now. It must be just buffering.
Imagine you just had an SR-71 Blackbird. You just followed the entire thing because it would be able to go as fast as the shadow.